Hello and welcome to KISS Math. We talked about the commutative and associative properties, and in this video we will cover the almighty distributive property. To distribute something means to give or spread something out. So if we have a term that's grouped in parentheses, like this guy here in blue, and it's being multiplied by something outside of the parentheses, like this A in green, the distributive property says that we can multiply or distribute this guy to each one of the individual terms within the parentheses and still get the same answer. So a times x, a times y, and a times z. And it would look something like this. And for example, let's use real numbers now. Let's say that a equals 2, x equals 3, y equals 5, and z equals 1. So I'll fill in these variables here. So we'll have 2 times 3 plus 5 plus 1. Now what I can do is I can solve this normally and say 2 times whatever's in the parentheses, which is 3 plus 5 is 8 plus 1 is 9. And so we just get 2 times 9 is 18. Now I could also use the distributive property and distribute the 2 to this 3, to the 5, to the 1. And so we would get 2 times 3 plus a 2 times 5 plus a 2 times 1. And if we solve these, this would be 2 times 3 is 6, plus 2 times 5 is 10, plus 2 times 1 is 2. And this would be 16 plus 2, 18. And you see we get the same answer as we did before. Sometimes it will make more sense to just evaluate it like we did up here, and then other times it'll make more sense to distribute. So far we've only dealt with positive numbers. If there are negative signs inside the parentheses, it's not so bad, we follow the same steps. So here we have a 2 on the outside, and inside the parentheses we have a 3 minus a negative 5 minus 1. If we want to distribute this 2, we do the same thing. We multiply the 2 to the 3. We distribute the 2 to the negative 5. And we distribute the 2 to the 1. And we keep whatever signs that were there inside the parentheses originally. So these minus signs, we're going to keep those. And if we do that, this would become 2 multiplied by 3 minus, and this minus comes from this guy here that was here originally, 2 multiplied by negative 5 minus, and that minus comes from here, 2 times 1. And remember, this 1 is positive, right? It doesn't have an extra negative sign attached to it. So if we were to evaluate this, 2 times 3 would be 6, minus 2 times negative 5 is a negative 10, right? Minus 2 times 1 is 2. And so then finally we have 6 minus a minus number, remember we said is the same as adding that number, so 6 plus 10 minus 2. And that is 6 plus 10 is 16, minus 2 is 14. So this is our final answer. Now, what if the sign is on the outside? So here we have the same problem as before, except the 2 on the outside is negative. Now, if we want to distribute this negative 2, we have to be careful because you not only have to distribute the 2, but also the negative sign with it. So if we distribute this 2, we would have a negative 2 times a 3 minus and we got the minus sign from here. Negative 2 times a negative 5 minus, which comes from this guy here, negative 2 times 1. And if we evaluate this, negative 2 times 3 is negative 6 minus negative 2 times negative 5 is a positive 10 minus negative 2 times 1 is a negative 2. So then we have negative 6 minus 10, so that's negative 16, minus a negative 2, and two minuses make a plus here. So we'll have negative 16 plus 2, which is a negative 14. Now, still on the same example, we don't have to distribute everything just because it's there. If I wanted, I could distribute just the negative sign or just the 2. So let's say I wanted to distribute just this 2, but keep the negative out here. It would look something like this. So we have the negative, and then we will distribute the 2, right? So we'll have the 2 times 3 minus 2 times negative 5 minus the 2 times 1. And all of this is still being multiplied by this negative out here because we did not distribute that. We just distributed the 2. So if I simplify this, we'd have 6 minus a minus 10 minus 2, which would equal, and this negative is still lurking out here, 6 minus a minus 10, so that's 16, minus 2 is 14. And now we can multiply this negative sign here, and the final answer would still be negative 14, which is what we got in the last slide. Let's say I just wanted to distribute the sign and keep the 2 out there. So in that case, it would look something like this. We'd keep the 2 out here, and if we distribute just the minus sign, which is here, it's the same thing as distributing a negative 1 to all of these terms. So we'd have a negative times a 3 minus, and this minus is we're keeping this the same here, that doesn't change, but we distribute the minus here to the negative 5 minus, and that's this minus we're keeping. We distribute the negative 1 to the 1, and our 2 stays out here. We haven't done anything with that. So if we simplify this, we have a negative 3 minus a negative 1 times a negative 5 is a positive 5 minus negative 1 times 1 is a negative 1. And so we would have 2 times negative 3 minus 5 is negative 8, minus a minus 1 is the same thing as plus 1, so we'd have negative 8 plus 1 is negative 7. And if we finally multiply that by 2, we get negative 14, which is the same answer we got when we distributed just the 2 and kept the minus sign outside. Okay, here's a super fun example. I've made sure to include a bunch of negative signs because you can't run from them. You have to know how they work. So what we have here is 3 times a negative 4 minus 2 minus 5, and then minus a parentheses 2 plus 4 minus 3. Now the easy way would be to just evaluate this thing, evaluate the parentheses first, and then multiply without doing the whole distributing thing. So if we do that, we would have 3 times negative 4 minus 2 is negative 6, minus 5 is a negative 11 minus 2 plus 4 is 6 minus 3 is 3. And so this would just become a negative 33 minus 3 equals minus 36. So we know what the answer should be, but let's use the distributive property now to try and get the same answer. So let's look at this first piece here. We know we have to distribute this 3 to all of the terms. And if we do that, we would get 3 times negative 4. And we keep the sign minus a 3 times 2 minus 3 times 5. And recall, we got this sign from looking at the operators here. Like that. This sign over here, that's a negative 4, so that's where this is here. Now let's clean this up a little bit. So this would be a minus 12 minus 6 minus 15. And that would be minus 12 minus 6 is 18, minus 15 is a negative 33. And so we would have this negative 33, and we still have all this stuff out here. So minus 2 plus 4 minus 3. Now this one trips people up sometimes because there's not a number next to this minus sign. And so they don't think they have to distribute it. They might just do, minus 2 and then continue on adding 4 minus 3. But what you have to do is minus 2, then distribute it to the 4, which makes that negative 4, and distribute it to the negative 3, which would make that a positive 3. So let's ignore this negative 33 out here. Let's just look at this piece here and rewrite this using the distributive property. So you just have to remember also that this negative sign is also the same thing as a negative 1. We just typically don't write the 1. But we can write it just to be more clear and obvious. So negative 1 times a 2 plus 4 minus 3. Now if we distribute this, that would look like a negative 1 times 2 plus, we're keeping the signs here, plus a negative 1, distribute to the 4, minus, from here, negative 1 times 3. And that would equal negative 2 plus a negative 4, that just becomes minus 4, minus a negative 3, that's the same as plus 3. And at this point, I can essentially rewrite this whole thing that we circled here. We can rewrite that as this. And if I do that, we would have negative 33 minus 2 minus 4 plus 3. And so I haven't changed anything. I've just rewritten this using the distributive property in a way that looks like this. And so if I evaluate that, that would be negative 35 minus 4 is negative 39 plus 3. And we get our negative 36 answer that we were looking for from the beginning. Now, if we didn't distribute that, just to be clear, if you look here, we would have negative 33 minus this piece. We can just evaluate this, right? So 2 plus 4 is 6, minus 3 is 3. And so you end up at the same place, right? Negative 33 minus 3, negative 36. But for demonstration purposes, we can distribute the negative sign and still get the same answer. So here's another example that I'll go a little bit quicker and show you how I would solve it without stopping to explain all the steps. So essentially we have two pieces here. We have this guy and this piece here. And I will distribute everything in order to solve this. So let's start with this piece here. So distribute the -3, the -4, minus, we keep the sign, -3, distribute that to the -2. And then we have this component. So again, we have to remember if we're going to distribute the -2 out here, that we distribute the sign that comes along with it. So we will have a -2 times 3 minus a -2 times 6 plus a -2 times 1. And what you don't see really is a hidden plus sign that kind of joins these two pieces together. I'm only going to write this here so you don't think we're going to, multiply this to this term here. Once we distribute everything, it just becomes addition and subtraction. Okay, so let's do this. -3 times -4 is +12 minus -3 times -2 is a +6. Then we have a -6. And then we have a minus a -12. And then a plus -2. And now we just simplify. So we have 12 minus 6 is 6. Minus 6. Two negatives here, so plus 12. Plus a -2, so that's just -2. 6 minus 6 is 0. And then we have plus 12 minus 2, so that's 10. Now I'm going to quickly check this answer, make sure I got it right, by solving this the other method, which is just evaluating this thing. So if we just do a -3 and evaluate what's in the parentheses, so a -4 minus a -2, that's the same thing as +2. So -4 plus 2 is -2. Then we have minus a 2 times 3 minus 6 is -3, plus 1 is -2. So this is the same as a +6 minus a -4, which indeed 6 minus a -4 is 10. And we get the same answer. So I know I've done it right, unless I screwed up twice.